Okay, let's go.
Hi everyone, a good day to you. My name is Nasser AL-KHARRAZ. I am from Group 3 and my group is doing IoT called aquaponic optimizing power water supply for sustainable agriculture. So basically our project is aquaponics system, which consists of 3 groups. For my group, our subsystems in the aquaponic in general are power supply, water supply, cooling, and we are also doing monitoring for temperature and humidity. I know those subsystems might not be really related to aquaponic like fish or plants or so on, but it is not about the relation to aquaponic, it's about how aquaponic is dependent on our subsystem. Definitely the aquaponic need the power for the electronics there to work and need the water supply for the fish, of course. Here you can see our poster. So now me and my teammates are going to explain our subsystems in depth. So let's get started.
Assalamualaikum and good morning. So now I will explain about the water supply that we provide to our aquaponic system. So this is our severe tank to harvest the rainwater. That you can see on the top is this as a netting to cover the inside from the other stuff to get in, like leaf or insect or anything. So this water supply is supplying the water to the fish tank. In case it's not enough or so, it will connect with this pipe and has the solenoid valve from here. It's connect from here to here. Then this water savior tank also providing the water for our water misting that you can see here, our misting for the cooling system.
Hello, my name is Muhammad Ifam Rasdi and I will explain about the power supply of our system. So for power supply, as for your information, we cannot use the electric and water in the school for our system. So we make a research that we have to use solar panel as our power supply because solar panel is easy to get the power. Because in Chandun we have monsoon day, which is more sunny day than rainy day. For the connection, we connect the solar panel to our solar controller, which is in the box here, and we use MPPT solar controller because it has more efficiency to provide energy to the battery. So from the battery we can provide the electricity to our electrical component. After that, we also use terminal to provide the power to the other group.
Okay, so for all 200 watt solar panel, why did we build it in this orientation? We built it with a tilt angle of around 7 degrees and pointed exactly to the south. Why did we choose that? That was based on a study done by UNIMAP and a lot of site visits that 7-degree tilt angle with pointing to the south is the best orientation to get the most amount of solar harvesting for Berlitz. I know we are rectangular, but it's still considered to be near to Berlitz, so it's valid. So we built it in this orientation to get the most amount of solar irradiance. As I previously mentioned, we are doing power supply not only for our group, but the other 2 groups in our project. So how can we extend the connection? We are actually using this type of terminal where we are connecting the positive and negative load here, and other groups can connect directly their load to the terminal, and the load will be delivered to there directly. So the special features of our MPPT solar controller, firstly, you will see that the solar panel is charging the battery, and when it is supplying to the load, let's say I want to supply to the load, okay, now it will be supplying to the load. So basically now the solar panel is not charging the battery because the battery is already full, and that's one of the main features of the solar controller. It will prevent the overcharge of the battery. Once the battery is already fully charged, then it will stop charging the battery. So the other special feature that it can provide two types of output, which is 5 volt through the USB and 12 volt directly from here for the load.
Hey guys, I'm Sarvesh here. I'm playing a role in this technical expert in for the group 3. So today I would like to talk about system development and also preventive method for making this project to ensure that sustainability and for a long run show. Okay, the first of all that what we have chosen is this type of beam, which is called painted beam. We have designed into this type of shape because in any strong winds or what, it will never bend and all. Second thing is it's painted, so when it exposed to heavy rainwater or any water droplets, it will never get rust. Second thing is all for the wires that we have been using, we have used covered with PVC tube, which ensures that there's no water inputs will be running into the wire, as I mentioned you again, because this is made up by waterproof material. Okay, next we will be talking about the pump. Okay, we have been using a water pump called 12 volt of water pump, which supplies to the water irrigation mist, as I mentioned you earlier. So this pump shows which about 0.8 MPa, which is a heavy pressure. Okay, so this produces a lot of sound, which we will attach in another video. Swipe left. So you have seen the video. So we have came up with a design where we came up with acoustic lining, which is a studio foam concept, which will be using this type of material to ensure that the vibration and noise which is reduced. And we have tested using free noise microphone. We have proven that there is chances and reduces of 2 decibel from the previous record. So this will be the cover, and it ensures that there's no water will be into, and the sound will be preventing from outside, which disturbing the classroom or also creating noise pollution. Okay, next we will be talking about the water irrigation mist structure. We have came up with PVC pipe, which we have already, for the prevention method, we came up with the white tape and the glue, and also we have put inside cements, which make it concrete, which it ensures there will be no hard shaking, and also even during the heavy windfall or if any obstacles hit the structure or the table of the plants, it will never collapse, because that's how we design. And also we design with a huge diameter where we can access easily from the shade. There will be no obstacles for us to, or any injuries, because there's no sharp edges. We have polished it, and not only that, this ensures that this plastic can ensure in high pressure, even you click hard and all, there will be no bend or dented will be happening.
Okay, I will explain about how the shade will cooling our subsystem, while Nasser will give the brief explanation how the mist irrigation will cooling the subsystem. Okay, for the shade we use 50% because we want the sunlight to go through half and half, because the plant need to have enough sunlight to grow. We use 50% because we make a research that said that 50% is the best for the plant, especially for the spinach plant.
Okay, so now I will explain about the cooling subsystem, which is via water irrigation mist. So the main component of the water irrigation mist is our deer pump here, which is 0.8 megapascal and can supply a flow of 4 liters per minute. So basically, the water will be sucked directly from our rain harvesting tank through the water filter. So after the water is have been sucked by the pump, it will be pumped exactly to the our water mist. So basically we have designed a system with 13 nozzles to ensure that all the plants are being covered, and through our design we ensure that there is no overlapping of the mist, because too much misting can affect the plant. So we try to balance between giving the plants a good environment, a good cool environment, and not overwhelm it with the misting. We are using this pump which can give 0.8 megapascal, which is strong because the mist need a strong pumping pressure to give us the best fine mist.
My name is Gan Shinsen. I'm going to explain about how we achieve the IR 4.0 on our system. We're using Blink apps to monitoring our temperature and humidity. Okay. Now I'm showing our solar controller and our ESP placement in the box. This is the solar controller, and that is our ESP32 that used to control our pump based on the temperature and humidity sensor by the DHT11 sensor. And that is the Blink apps that we can monitoring our temperature and humidity and also control our pump. When in the manual mode, we can manual open our relay. Let's manual open the pump to spray out the water, and we can close it manually, and we also can make it by automatic mode. This automatic mode will open based on the temperature and humidity that I set based on the capture from the DHT11. And this is our DHT11 sensor to capture the humidity and temperature. We place inside the shader to make sure it can more easily to capture the temperature and humidity for the plant. The temperature and humidity value we also can see from our Blink apps, which is view online, and also from our OLED screen outside of our box.
So for power supply and water supply, okay. So for cooling, okay, plants need to be cooled. Of course, it's healthy for the plants. Otherwise, the sun will really affect the plants. But for power supply, water supply, why exactly? The challenge comes here, because we are doing it in a restricted water and power area. So we cannot have power supply or water supply. So that's why we came up with the idea that we need to stand by ourselves and have our own independent water source and power source. Before getting into detail, let me explain to you our subsystems. For power supply, we are using the main source, which is the solar panel, as a backup source, battery, which will supply the power during night. For the water supply, we are using rain harvesting through water tank. For the cooling, we are using shade and water irrigation mist, and basically we are also doing the monitoring for temperature and humidity.
Right, so this will be our poster that we have created. So this can be a reference for you all. Alright, I'm here back again for concluding this project. In a nutshell, we have few challenges that we have to overcome, which is one is power supply, second thing is water supply, because they are restrained from us using from this smart cell school. So we have invented through natural resources and renewable energy, which is one is solar energy, another one is natural rainwater harvesting. So basically this is a big thing for us to achieve, that our group 3 have mainly achieved what the main challenges is really about. And I would like to thank every single people who have supported us till this end. and taking this gratitude of us that we have already accomplished with aligned with SDG, which is SDG 6, SDG 7, SDG 12, SDG 13. And I hope this video helps you a lot. Please do share, like, and subscribe to our YouTube channel. If you want more content, you can refer to our thesis paper that we will attach in future. So take care guys, and signing off, your Sarvesh here.